Alright, we are back. So we are currently at the stage in our build where we have completed the X-axis along with the Z-axis. We've attached the X carriage. We've done a lot of work here. We just completed, it's going to be step 4 in the build manual. We're now going to move on to step 5. There's step 5 left. Looks like there's about 45 steps. This is moderate difficulty, so I think this one will actually take a little bit longer. We're going to be building with some tiny pieces for the Nextruder. What's left after this is the XLCD assembly and then installing the Y carriage and heat beds. Both of these I think should actually be, yeah, see this one's easy, 41 steps. And then the Y carriage and heat bed is also probably going to be about 56 steps since moderate. So probably just a lot more running of wires. So anyways, today we're going to try and get this done. We're going to try and just do the Nextruder. It is going to be a slightly more challenging thing. For those who are probably watching this for the first time, we are building a Prusa MK4 with custom ABS parts. So the ABS parts were printed on a different 3D printer that's not a Prusa. But these are printed in Galaxy ABS. This is Galaxy ABS Teal. And this right here is Galaxy ABS Gray from Polymaker. The Galaxy piece means it just has these little pieces of glitter inside of it. I have the parts here behind me, so things have changed since the last time we did this build. Previously I had all the screws and everything on camera. I went ahead and moved them off, cleaned the table up. It's going to be a lot easier to work and hopefully see things. And here is a quick demo of that part. Notice the sparkle. That is not the filament sparkling, although part of it might be. But in there is, see, now it doesn't want to focus on this. But maybe this is actually a lot more visible. There is some glitter in there. If I get it really close, nope, it's not going to work. All right. With some of the parts too, with the Nextruder section specifically, we are going to be doing the planetary gear alignment. And supposedly you cannot print this planetary gear alignment piece, this one specifically that comes in the kit. You cannot print this on any printer other than a Mark IV. So they're printing these on Mark IVs, and there's something extremely specific about this and about its tolerances. I have one here in ABS, and it looks amazing. It's not going to go in the printer, it's just used for alignment. And in terms of the print on it, it is near identical to the piece. Like, I'm looking at where this piece ends, and I cannot tell the difference unless it's in like microns. This difference, there's not a I guess maybe there's a slight little difference right here on the corner, but could that really make a difference? So when we actually get to installing the gear, I'm going to do that really slowly. I'm going to try and show that as best as I can on camera. I'm going to try to use my part, although we'll see if we can actually use it. I wonder if we'll be able to visually see. Maybe we'll try with this part. We'll try to visually see what is it doing, why do we need this part specifically, and why will this one not work. And then maybe we'll try our own part. I think the main goal is just to make sure that those planetary gears move and don't grind. So, alright, the way that we do this is we go ahead and we read the manual. So we'll read a step in the manual. If there's any parts to be collected, I'll go ahead and collect the screws, and then we'll go ahead and do the assembly. For some of the really long screws and a lot of turning, you just watch me turn screws, so feel free to skip forward if you don't want to watch that part. I'm here. I'm on chat if you want to chat. Here for comedic entertainment, and I'll give random comments here and there. So without further ado, let's go ahead and get started. So Chapter 5, the Nextruder assembly. I actually haven't been eating the gummy bears, so I'm a little bit disappointed in myself. We're going to need all these different tools in here. I have them in front of me, and I also have different versions of those tools that are a little bit easier to work with, in my opinion. but I have all the tools in front of me. So we can go ahead and jump right in. So filament sensor part preparation. We are going to need the Nextruder heatsink, the Hall filament sensor, those are those two parts right there. We're going to need this Prusa ball holder, which that part doesn't look to be 3D printed. That one looks a little bit too crisp, so I'll go look for that part right now. We're going to need the 3x3x3 magnet. That's most likely going to be this circle magnet down here. There's a spring, there's a steel ball, and then there is also a M2.5x6RT screw. So we'll take a look at that one, see what it is. So let me start collecting these parts really quick. Nextruder heatsink. If you're watching this at a later time, feel free to just skip past this. It's going to take me a minute to grab all these parts. Alright, I got a Nextruder heatsink right here. I have the, that's just the Nextruder itself. I have a planetary gear. Wow, that's pretty cool. I have the Hall filament sensor. I'm going to put this planetary gear back. It looks to be partially assembled actually in there. So I assume that that's going to be a fun piece. I'm really looking forward to doing that planetary gear. Alright, let me see if there is a bag of parts for the Nextruder. There is a parts bag. So I am just going to grab the entire parts bag. We're most likely going to need a lot of the parts out of the bag. I do already have the Nextruder printed parts. There is 2 bags labeled Nextruder. I recommend just finding those Nextruder parts if you're building this at home. Have them handy. We're going to most likely use all of them. For the Nextruder, I also was looking at some of the parts and thought, oh, it'd be really cool if I printed some of the parts in color that maybe they don't print in color. So I have a few variations of parts too that are printed in either gray or teal, and I guess during assembly we'll look at it and we'll make a decision, let's go with this one. One thing to note is for some of these parts, specifically for the Z and X axis, I did have to reprint them because the original parts were a little bit too tight. So I went ahead and I reprinted those and we assembled those yesterday. Although there could be Nextruder parts, and I assume with the Nextruder having tighter tolerances, we might find ourselves in a situation where we have to reprint this, where we may have to reprint parts. So it is a possibility that we won't get through this installation today. We'll learn something new, we'll take it back to the drawing board, and we'll continue on. So, alright, I have these 2 pieces. Let me grab these. I have found the ball holder. I have found the 3x3 magnets. They are, of course, stuck to one another, as magnets do. So, let's go ahead and put that one right here. I think it's actually pretty cool. The magnets are packed in SD card holders. Kind of innovative. Very different. Very new. Alright, Nextruder, springs and magnets. And there's a ring in there, so they should just put springs and rings. We are going to need the spring. Oh, there's a smaller one. Both of these are the same size. I need to look back into the parts bag because I need the smaller spring. Let's see. There is 2 springs that are 15 by 5 millimeters, and then there is 1 spring that is 3 by 9. So I do not see a 3 by 9 spring in this bag, unless it's attached to a magnet or it's hiding somewhere. Where are you? I assume this says Nextruder springs, plural, so all of the springs should be in here, but I don't see the spring I'm looking for. It is not in there. Uh-oh. Already the ball's trying to roll away from me. Need to get it. The table is not completely flat. Oh! The spring is hiding within the other 2 springs. That is actually very funny because this spring is tiny. So I'm over here looking and I see these two springs and the focus is not going to be that good, but here's kind of a size comparison in my hands. I don't have very big hands, but those are the springs. The one you're looking for is like that big. Look at how like tiny. Sorry, the contrast isn't that good, but in comparison, it's about half the diameter and half the height of the other ones. So, kind of hard to find. Alright, back to the parts right here. So we need the smaller spring. I'm glad they put in, in quotes, smaller one, because I almost pulled out a big one. It wouldn't fit, and I'd be here thinking, why is it not fitting? And we're going to need the 4mm steel ball that is also inside this little baggie with the springs. Alright, and if I attach it to the magnet, it's not going to roll away. So that's my goal right there. Okay, I have these pieces. The last piece I'm going to get is this 2.5 by 6 RT screw. I don't actually know what the 6 RT means. And if you are following along at home, it is going to most likely be in fastener bag 2. Yeah. Fasteners 2 out of 2, M 2.5 by 6 RT. Let's see how many of these are in here. And why such a specific screw? Alright, there's 2 pieces in here, and one of them's a spare. So we will actually only use one of these screws, and here is where we are about to use it. I wonder if the heatsink itself just has some sort of very specific use for this screw. Upon observation of this screw, oh, okay. So the 2.5 is the diameter of the screw. The by 6, the 6 is the 6mm length, so it's a very short screw. I don't know what the RT is, or at least the R. The T means Torx. So it is not a hex screw, it is not a Phillips screw, it is a Torx screw. So that is what the T stands for. Not sure what the R stands for. R, maybe rounded top. It's not a button head or socket cap screw. So alright, we have all the parts. Here's how we're going to assemble it. We're going to go ahead and put the Hall sensor inside of the similarly shaped pocket in the heatsink. Very simple. Fix it with the screw that we just got. Tighten very carefully. You can crack the electronics board. Okay, so how tight should we tighten this? Assemble the Prusa ball holder in the following order. Steel ball, then magnet, then spring. Insert these parts into the Prusa ball holder with the steel up. Okay. I have 2 of those already. I already put the ball on the magnet so it doesn't roll away. So it looks like I just have to add the spring to the other side of the magnet. And then it's going to go in spring first into this filament sensor. The filament sensor is not 3D printed. This looks injection molded. Very crisp numbers. Just a very crisp part. So, I guess we're moving away from the 3D printed stuff. Alright. Let's look down right here. Here's where the first assembly is going to happen after a little bit of auto camera adjusting. So, here is the second filament sensor assembly. It goes spring, magnet, ball. I'm going to put that in right now just so I don't lose it. I have it ready here in my filament sensor. 10 out of 10. That was super easy, which scares me because this section is of moderate difficulty. Here is our heatsink. The heatsink actually, if you look here, has built-in load cells. So they can measure how much, I guess, weight is being applied here, which means they're going to get some really cool data. But it's kind of cool how load cells are made, and there's like patterns to them, and some crazy cool engineering that allows you to measure weight and forces. And here is our Hall effect sensor board. At the end of this board is most likely a Hall sensor. and that is somehow going to work here with this steel ball in order to detect the filament when the when the ball is pushed away. Let's assemble it and let's see where it goes, and then we'll be able to better understand how this works. So, board goes in first. It fits into the pocket here. So here is our board. Went ahead and just popped it right into the pocket. It has quite a bit of give in there. It didn't really click in or anything. We are going to need a Torx head Allen key. So notice it's a star rather than six-sided. Find the right one that fits the right size. This one fits this screw, and just start turning it. There is a smaller Torx screwdriver that I tried using, so that means there's even smaller Torx screws somewhere. This Nextruder might be a really cool thing. I am just lightly tightening this. They didn't want any sort of pressure applied, so I just kind of got it to tightness. I didn't do any quarter turn. It's in there. I guess if it gives problems, I can come back and tighten it in the future, but I'm not going to over tighten this one if they say that, you know, be careful, you might break the board. So look at that. There's a little spot right here, most likely for the filament sensor. Let's do some prediction here. This piece right here is most likely where filament is going to travel through. It looks like there is a hole right here, and that hole comes from the top and goes all the way through. So, and this is probably where the planetary gear, no, I would assume that this is the hole where filament travels through, because the sensor, this little filament thing that we built here, looks like it'll fit there perfectly. And also there's a little ball, like a kind of a cutout inside of there, where if filament were going through this hole, it would touch that ball. So that's my prediction. Let's see if we're right. Moving on to the next step. Look at that. So the filament sensor goes into that piece. So insert the Prusa ball holder assembly into the heatsink. Make sure the steel ball is closer to the side of the heatsink. Note the correct orientation of the Prusa ball holder assembly. There is a protrusion on the part. The protrusion must be facing down. Push the assembly into the heatsink. So we're looking for that protrusion to be facing down. It looks like there's some flat sides that face up, and it's most likely going to click in. Now, why do we have to put it that way? So notice there on this piece, this protrusion needs to be facing down. Now the reason for that is, here we have a magnet, we have a steel ball. That Hall sensor is going to be able to sense if that magnet's there or not. So when the filament comes in and pushes this, there will be a magnet, and that Hall sensor will activate based on where it's positioned. Notice the Hall sensor in there. Notice it's not all the way in. Now the reason that we go downside like this is because the holes in here actually allow for that magnet to be, I guess, seen by the Hall sensor. I think Hall sensor would work through plastic, but you don't want obstructions. It will definitely kill the signal. So I'm going to go ahead and put it in the correct way here. So protrusion downward. Make sure that ball kind of falls into there, and just push. And at some point that clicks in, and we are clicked in. I'm looking from the top, and I do see the ball. So it looks like that sensor. Look at that. Even on this side, that protrusion. Let me see if I can get the autofocus. That protrusion fits in right there next to this custom PCB that they have here. So really cool. It's gone a really far way in filament sensors. In the Mark III that I built, I've gone through, I think, 3 different filament sensors, because it was the Mark III, then the Mark III's, then the Mark III's Plus. And each filament sensor just kind of moved that filament sensor and how it worked to a different spot. So kind of cool to see. This one, from an engineering standpoint, seems very reliable. Let's see how reliable it actually is in practice. Alright, the Nextruder idler assembly parts preparation. So let me go ahead and grab all these parts. I'm just going to move this piece off to the side so we can go ahead and grab the parts that we need and assemble what we got going here. So we are going to need the idler leveler B and A. That should be in this baggie. I'm going to go ahead and make sure I grab both my ABS parts and the original parts. I do like to compare the two. One fun thing that happened, so when I got my kit, immediately after they released new parts. And I've been trying to compare. I feel like the parts in my kit are already their new version of parts. But July 4th, I think they went and actually released the parts online. So if you're building one of these and you are downloading your own parts, they did release them. There might even be new ones right now, with slight modifications. You know, sometimes makes it easier to build this thing and do stuff. So, cool. Okay, let's make sure I have these. These are both different sides of the idler. They are not labeled, but that's that one and that's that one. All right, and then we're gonna need some stuff. So we're going to need the bearing 6932RS. That's going to be in the Nextruder parts. If you are looking at it, that is the only bearing in this bag. So just find the bearings. They're kind of small, not big. We're going to need these bearings. One bearing does look like two bearings, or maybe that is, but no. They have like a little cut on them, so they look like they're two stuck to one another magnetically, but they're not. So we need that. We need the 2.9 by 8.5 pins. There's two of them. They are going to be inside of this baggie as well. Yes, they are the tiny bins pins floating around in there. Let's see. They are actually in the Nextruder springs and magnets baggie, and the smaller baggie that we just had to work with a second ago. So we got that. We are going to need an M3x6 screw and the tubular spacer, 13.2 by 3.8 by 0.35. Wow. Talk about extremely specific sizing. Someone really catted this part up. It kind of scares me with modifying the parts and going ABS for this extruder, to be honest. M3x6 screw. I got all the screws here behind me. You don't want to watch me digging through screws anyways. That's boring. M3x6. Also, if you're watching this at a later time, feel free to skip on forward. It's just me looking for parts, doing boring stuff. Alright, let's see what's going on. Not too many viewers. Okay, got everything. Let's actually just move on to the next step. I got all of these parts. Assembling the extruder idler. So insert the pins into each bearing. Place both bearings with the pins into idler lever B. Close it up with a idler lever A and secure it with the M3x6 screw. Do not over tighten the screw. Both bearings must be able to rotate without significant resistance. From the same side, push the tubular spacer into the assembly. So that's how they're going to go. And you're going to put the piece on top. Push the tubular spacer into the bottom of the tubular spacer must be flushed with the bottom of the idler assembly. Interesting. Okay, so we are going to want to make sure that we build it in this way and figure out which part is B, because they are mirror parts of one another and they look exactly the same. So before we continue on, here's the parts that we have, and here's just a quick comparison of the parts. The parts one on top of another are, to my eye and even to my close eye, identical. These parts were not reprinted to compensate for size variation. And even if it was reprinted, the size variation here would be minuscule, where the slicer might not even actually catch it. and it might just print the same part. So we get lucky when the parts are small because you know, there's only so much definition you can also get with a slicer. So here are the parts A and B. I'm going to move the original Prusa parts off here to the side, and here are the parts that we need here. So let's identify which one of these is the B part. It looks like, so this part has a area for a screw and it has the indentation, and this part does not. So I bet that's going to help us identify which part is this B part. So we are going to put the bearings into this part, and then there's going to be a part here that has the screw, and this tubular spacer is going to go down on the same side as the screw and go flush with the bottom of the idler assembly. So notice it's going to protrude out on the same side as that screw. So the piece that I want on the table is going to be the part without the screw. So that is this piece right here. This part has the screw. So let's go ahead and assemble. I'm going to grab a bearing. I'm going to put one of these little pins into the bearing, and I'm going to pop it in right here. And that fit pretty well. It does not have a sticking outside, so it just kind of pops in and stays in. And that actually popped in real nice. The screw size is on point, not too much pressure required to get that in there. Alright, moving on to the other one. Put it in. Quick bearing test, they spin freely. Let's put the top part on. This is going to require just a little bit of force. Actually, not even, you just kind of squeeze it together. The bearings are still rotating freely in there. There's nothing holding them back. This part where the screw goes through is a complete through part, meaning it's going to thread into plastic. And the thread into plastic piece also means that we don't want to screw this too tight. Like it's just going into plastic. If we keep screwing, it's just going to rip out the plastic and not hold. So I'm just going to screw in until the screw is flush and it's just holding together. So, okay, I'm happy right there. Actually, am I happy? It looks like I went in and I screwed it in and I have this gap. I think the gap was created because I wasn't holding it close enough when I started screwing, so I might have screwed myself here by threading the bottom piece with something that just has a gap. So, alright, I'm going to push it down, no more gap. It seems to have removed the gap by just applying a little bit of pressure. Look at that. I am happy with that. And both of those bearings are still spinning very, very freely. Alright, and now the final piece is this extremely specific pin. This pin goes in from the top. It has a little bit of a tight fit. I'm going to go ahead and push it down with something else because it has slightly sharp edges. Okay. This one's actually a little tight. So, there we go. Okay, and it is bottomed out there. So cool. It looks like the hole was actually, with the ABS, a little bit tight. It makes it through if you apply the pressure, but we want to go ahead and we want to clean this up right here. There we go. So, look at that, and we are flat on the side. We want the protrusion on the same side as the screw. And I guess later on, if we don't want it here, we could push it through if we messed it up. Alright, we got this piece done. Let's move on to step 7. We're on step 7 of 41. Doing pretty well here. Pretty good pace going. Alright, the extruder parts preparation. Ooh, planetary gear assembly. This is the part that I was a little bit worried about. We're going to need the PG case. and that's just the front piece. That says Prusa on it. I printed one without Prusa. That's just not printed, and I'm on the fence if I should use it or not. I kind of like their part because it says Mark IV on it, but I'll determine later if I want to use it or not. We want to use the PG front case, that plastic piece next to it, the main plate. I have my printed and non-printed PG assembly adapter, and I'm going to go grab the PG ring and the planetary gear. So right now all it's having us get is the big ticket items. It's having us just grab the planetary gears and the big plastic parts. So I got some planetary gears here. They're assembled in kind of a weird way, and I'm afraid to just take them out. And this brass, beautiful PG ring. About to do a home shopping network here. All right, assembling the extruder parts preparation 2. We're going to need the extruder motor. The extruder motor is the last motor here in my kit. It is the smallest motor. It has a the motor shaft actually has it looks like it's going to mate with that PG planetary gear. So it's kind of geared. It has teeth. I'll show you that in a second. And it looks like we're going to need some screws and space. Oh, we're going to need some lubricant as well. So we're going to get the M3x25 screws, 3 of them. Alright, there is 4 M3x25 screws left, and 1 is a spare. Therefore, we have just used our final M3x25 screw. How exciting is that? That we have used it all. Alright, I'm going to move this screw off to the spare pile once I know I'm done, so I don't keep looking through the same bags. We're going to need a spacer. We're going to need a socket set screw, M3x25. What? And lubricant. What is a socket set? Oh, look at that. That's an interesting screw. Where is that in all of these baggies? Socket. Look at that. It has its own baggie. It's most likely going to be the only screw in here, because that looks like a very interesting screw. And then also we're going to need spacers, 5x10x0.1. I see some washers here, but they are definitely not the correct ones. I found some set screws, but they're definitely not the right one. Look at that. There is 2 of them in here, and 1 is a spare, so that's exciting. Alright, and the spacers are not in the fastener bag. Looking at the Nextruder parts bag of metal parts, there is 1 spacer, 5x10x0.1, and that spacer is just kind of floating around in the, oh, it's in the bag with the springs. No, it's not. Yes, it is. Yeah, it's in here with the bag with the springs. So if you've been playing with the spring bag, just go ahead and grab that piece out of there. So, I got so much part preparation for this one. Okay, I'm going to move these further off to the side, so they're just off camera, and I'm going to grab the lubricant, have it ready to go, and one of these, let me open this socket screw thing as well, and let's look at parts. Let's see what this thing is made of. Let's go with something done with. Alright, we are back. So, let's take a look at everything. We already talked about the planetary gear assembly at the beginning of the stream. Got all the screws here. I got this piece right here. These are the plastic pieces. Like I said, I got 2. Kind of on the fence on which one to use, but let's see screw alignment with these. Well, those screws look dead on. So I wonder if I just messed up printing a few of these parts. One piece that I might have to move is noticed in Prusa's, they have this like little rubber gasket in here. I didn't see it with printed parts, so if I'm using my own, I'm gonna have to figure out how to move that. I assume I could just kind of pry it up and move it. I guess let's try doing that now before we continue on and get disappointed. I have my screwdriver set right here. I'm going to just grab the flattest screwdriver. I see under it there is a little bit of leeway that I could try to get under and push it upwards. Move this off to the side, move this one even further. So can I disassemble this? Wow, it's in there. Looks like there's like a hole here. Maybe it's to be able to pry under there. Alright, it is not coming out. And I don't want to destroy this part. Oh, look at that. I got it out. So you just gotta push it up. It has an extremely tight fit, but it is a injection molded part that's probably just gonna hold the gears where they need to be. Let's see if it fits my part. Pretty. It is not gonna fit. Yeah, that is not gonna fit. Let's see. I have part from them E6, and my printed part is R3. I definitely did not scale this part, so this part is not scaled, and while the screw holes look to be fine, this is not. So it looks like we're not going to be using this. So what we're going to do is we're most likely just going to use this original Prusa part. If I decide that I want to replace it, I'm pretty sure it's just the front of the printer, and there might be some things to consider when replacing, but it might be just something that I can go ahead and replace. Alright, let's see. What else is cool that we have here? So we talked about this part, we talked about those. Those are just the screws. Here's the paper thin spacer. That's kind of cool. This we assembled in the last step. Let me move that off to the side. Here's the brass planetary gear holder. This is a machine brass part. Just gorgeous. Has a lot of teeth. I don't think it looks like it's mirrored to itself. So the motor here is the thinnest motor that you'll find in the motor box, and you'll notice that the shaft of the motor actually has these teeth. I'm not getting good focus on it to be able to show you. Is it going to focus? Look at that. Oh, come on. Look at those teeth. And they're going to align with the planetary gear. This is definitely a custom motor. It says Extruder on it. And the star of the show, the planetary gears, they look to be assembled in the bag. So I'm going to try and take them out carefully. Oh yeah, there is some sort of assembly going on here. These are the planetary gears. And something is going to happen where through the middle, the extruder is going to come in, and then they have to all mate correctly. So, oh boy, I spun one of them. I'm sure you can probably spin them, and it would be okay. But they're going to have you do this alignment to make sure that all of the teeth go in the right spot, because if the teeth don't align, something's going to start grinding, and you do not want grinding. Metal on metal, essentially you won't have an extruder. Alright, let's move on to the actual build, and I have the lubricant here on the side. Actually, one other cool part is this M3x25 socket screw, or I forget what this thing is called, but it's actually set screw. The motors usually have these like screws that don't have heads, but this is a screw where the tip of it, I guess if I go really close it'll focus on it, has a piece like that. So you put the Allen key in and you spin it. So, alright, refocus please back onto what we're working on, right here. Please, right here. Yeah, okay, there we go. Love it when technology cooperates. Assembling the extruder. Attach the 5x10x0.1 spacer over the shaft of the extruder motor. Okay, interesting. That looks to be very important because there's a triangle. Place the heatsink on the extruder motor. Note the orientation of both parts. So the heatsink is going to go right there, and we're going to be looking at where that cable's going. The motor cable must be facing up, quote unquote. So we'll just make sure that we have the same orientation. The heatsink cables must be on the right side. So what's important for us is the heatsink is, I guess, laying down. The cable that we attached here is on the bottom, so it's not going to be visible. We're not going to see it. We are going to see that ball assembly that we assembled. And then attach the main plate on the heatsink. Note the orientation of the part. That's this piece right here. This main plate will go on, and we're going to note some sort of cutout here on the heatsink. Before proceeding to the next step, make sure the spacer is placed on the extruder motor. That spacer must be extremely important. So let's go ahead and I will make it one entire step just to also signify the importance of this. Here is our motor. We are oriented about the same way. Here looks like a good spot for it. Here is the spacer. The spacer is on the motor. And actually, I don't think this is that. Look at that. There's a little bit of a magnet there. I don't think this spacer is doing anything other than it's a very snug fit. It's right around that motor head. So if it's like magnetized on there now, it doesn't want to come off. But under it, there's actually like a slight hole. So notice that the motor has this hole, and the moment you put this spacer on, that hole gets covered. I wonder if this is on purpose the thinnest possible washer you can order or find specifically to block that hole and prevent crap from getting inside of your extruder and making it do fun stuff. So, alright, so we got this piece on. Next we are going to grab the heatsink that we previously assembled. Notice the ball parts are right here, and it goes on like this. And notice do this. Notice the cable for the motor is right there, and notice that we don't see the board. And we're also going to have to install this part right here, noting that this cutout right here goes right there. So let's go ahead and put this piece on top. Alright, I think we are good. There's some interesting spacing in here as well with this part. So there's actually some cutout in here. It looks like for the filament to travel. So that part right there. Come on, do the focus thing. Right there. There's a filament path for it to travel on. So that looks pretty good. Let's put it back down the same way. I think the next step is going to tell us to use the M3x25 screws to go ahead and attach it. I'm going to validate again. That washer is on there. It's being pushed up by, it looks like a magnet. And I got all the parts oriented the correct way. Assembling the gearbox. The following instructions need to be done correctly and carefully. Achieve better understanding and successful assembly by watching the video alongside the guide. Oh my, there's a video. Okay, attach the PG. So we're going to read the instructions and we're going to go watch the video. This part seems to be extremely important. I'm also currently just holding this from it falling apart. So I'm going to let it go. I'm going to let the part sit there while we watch this video. So let's read the instructions and let's go watch the video. Attach the PG assembly adapter on the PG assembly. Note the pockets for the gears in the adapter. So those pockets exist right there. So you go ahead and you put that on like that with the gears. Assembling the PG ring. Do not assemble the gearbox without the PG assembly adapter. This tool is intended to ensure that the gears are correctly fit together. Okay? Note that there is a chamfer on one side of the PG ring teeth. This side must be facing down to the PG assembly. So there is a chamfer on these teeth. Oh, okay, there is the slightest of chamfers. I wish they'd put something on the front to make it easier to see. It's there. It's kind of hard to see. So the chamfer side. Note there is a chamfer on one side of the PG ring teeth. This side must be facing down to the PG, so it's going to go, I guess, upside down almost. With the other hand, slide the PG ring onto the PG assembly in a wobbling motion. Move the PG ring left and right repeatedly. A quarter turn is enough. We are going to have to watch the video for this. That sounds confusing. So we're getting these external gears here into the brass ring. Stop when the gear surfaces are flush with the PG ring surface. Okay, so we're going to kind of wobble them in. And then we're going to grab that whole thing with the assembly. Proceed very carefully. This might be the step. Very gently and freely rotate with the whole PG assembly until it drops down so there is no gap between the assembly and the main plate. Do not push on the assembly. Remove the PG adapter. Okay, so we're putting it, we're trying to make sure that the gears align. And I guess it's going to have us check for the gear alignment. So then checking it, attach the PG assembly adapter back onto the PG assembly again to verify that all parts are properly seated. Rotate with the PG assembly adapter. The movement of the PG assembly must be smooth and there should be no resistance. Remove the PG adapter. You will no longer need it during assembly. We recommend keeping it for maintenance. Make sure both PG ring and PG assembly are sitting flush. There must be no gap between PG ring and the main plate. If you see a gap, remove the planetary gear assembly and reposition it again. So there should be no gap between all of this. Oh boy. I think that's the important parts. And actually, once we put that on top, it's just sitting there. I guess there's going to be the pieces holding, but all right, let's go watch this PG assembly video. 1 minute 22 seconds. So chamfer down. Whoa. Sorry. I need to rewind. Slide the there is a chamfer on one side. This must be facing down. Over that PG ring adapter. Grasp so it can be rotated. And then you're doing a wobbling motion to get it onto the rings. That's what they mean. Stop once they're flush. Awesome. And then we're going to put it onto this with that ring still on there. Okay. Oh, okay. Got it. So we're just spinning it onto that. That's not that complicated. So we put that adapter back on, and we can actually force them to move. Okay. Wow. Okay. I mean, it looks scary. I think let's do it slowly, and we can get this done. The gearbox, we got this. All right. So step 1, we're gonna put that piece on to the gears. Step 2, we're gonna put that brass ring on with the let's see, chamfer. The side, this side must be, so the chamfer is facing down, away from the plastic piece towards the big piece. Is that right? Yeah. Purple. It's facing downward. let's go ahead and get those two pieces done. So I'm going to just move this off to the side because we're going to need to assemble it onto there here, or in a second. I'm going to start with their adapter, just to play it safe, do it once, and then I think I'm going to try it with my printed adapter, although I guess what am I trying to achieve? So here is their adapter. That is a very snug fit. I'm just curious at this point. Oh, yeah, my adapter, I can force it onto these, but it's not going to fit. And this is not scaled either. So, yeah, don't use a printed one. Use the original one that came with your kit. This one right here is good. The nice thing is once this printer is built, if you want to build a backup one, you can go print one of these. The tolerances on this printer support printing that. So, alright, back to assembly. We're going to put this on, and we're now holding it in place. We are going to find the chamfer side, that is this side, and we want it going away. So the chamfer is at the bottom, so I'm going to put this on the top, and I'm going to do a wobbly motion to get this installed. See if I can do this better on camera. Oh yeah, making sure that these go into the right part is important. Yeah, because the gears could definitely go in here all crooked. Okay, hold on. I do not have this correct. We need to try again. I do not want to screw this part up. Let's take a look at the browser one more time. It looks like, oh, so we're going to go on a flat surface with this planetary gear adapter, and then from the top I'm going to put the brass on. That'll give me the right leverage. Then I can pick the whole assembly up. Once I have the whole assembly, I can then place it on the extruder. Okay, good plan. Okay, so let's put this planetary gear back into this holder. So I have it right here. And we are back. Alright. Had a slight little glitch there. Seems to be happening regularly now. I wonder if it's like time-based. It is currently 10 p.m. here on the West Coast, so maybe that has something to do with some sort of update. Alright. Totally got us off our game. So back to this planetary gear assembly. This PC in here is slowly falling apart. Make sure we align it properly. Right about there. So I got this planetary gear here, and I got it on a flat surface. I'm just going to be doing a spinning motion from the top. And what's important is this top piece will help us guide it down onto the planetary gears. I'm just going to be doing a wobbly motion. It's very important that you go top down onto the gears in order for them to align properly. And that chamfer is there at the bottom to help them fall into place. And you don't want to apply too much pressure. Really, probably no pressure. Oh, there we go. I got it in. Alright, and we're going to keep going until we're flush, which is right about there. Were we flush yet? We are almost flush there. Oh, almost flush. Just a little bit further. Okay, and we are good. Planetary gears are in. Now grabbing the entire assembly, holding from the bottom, we're going to go ahead and place it on here. And also, we are now going to start spinning it until it falls onto the motor. There we go, and we got it in place. Do you think it'll have us check to make sure that screw is still there? The spacer. So, okay. We got it. There is no space between the part and this brass piece. And just to make sure, I think, alright, the bottom piece spins, the top piece does not. I wonder if it should or it shouldn't. I'm going to look here now to see the alignment. So I see that the planetary gears are aligned and the teeth look in. Now it looks real nice. Alright, so maintain the position and attach it to the extruder shaft. Very gently and freely rotate with the whole PG assembly until it drops down so there's no gap between. Do not push on the assembly. Okay, did not do that. Remove the PG assembly adapter. And then attach the back to verify. Rotate the movement must be smooth. There should be no resistance. I feel like there is quite the resistance. So let's actually try again. What I didn't do is I kind of tilted back and forth on that final part, and I don't think that part needed to be tilted back and forth. So let me go back to camera mode because it doesn't help. Oh, I'm already in camera mode. Look at that. Apologies. So I got the PG assembly adapter on top, and it rotates freely when not attached to the extruder. Does it rotate freely? Seems to rotate partially and then kind of gets a little stuck. Let's see, how are those teeth making contact? The contact seems to be good. So I'm going to rotate it all the way. Okay, I have full rotation. I think it's actually just the plastic grabbing a little bit of the walls. So, alright. Now, next step is to place this entire assembly on top and just spin. I'm applying absolutely no pressure. I am just spinning. And hold these other pieces so they don't fall off. Well, the last assembly was much better at this. Oh, I think we're there. I think we still have a little bit of a gap, so let's spin it a little bit more. I think what the issue here is the gear actually fell into the brass. Oh, we have to do it again. This is probably not good to take that piece out, is it? Can I just flip it upside down and remove it? I can. You just got to do it gently, not to damage the gears. Alright, I underestimated the complexity of this. I definitely did. So, I wish there was something to hold that together too. Like a little... Look at that. Our part was useful for something. Alright, let's try for the third time. So, assembly on the table. Gonna go ahead and get this in there. Alright, we are good. It is being held in place. Let's start with the brass ring coming from the top. We're gonna spin it slowly. This one wants slight turns. Just like that. I'm applying no pressure. I am trying to get that brass plate straight on here so it actually falls in with that chamfer. This piece is actually really hard to show on camera. Go ahead and get that piece in there. Gonna spin. We're gonna go to the other side. We're gonna spin it. Okay, and we need to go a little bit further. Alright, depth is good on that one. This one, we need a little bit more depth, so just back and forth, we rock it a little bit. They are now flat. So, probably can't see that, but that is pretty flush. If anything, maybe extruding just a little bit past the surface. Don't come out. We didn't ask you to leave. Alright, now, onto this assembly here. We're gonna put it down. We're gonna line these plastic pieces, and we're gonna just spin like this. I'm applying no pressure. I'm just waiting for the gears on the extruder to kind of fall into place, and it looks like they clicked in. They have to fit perfectly. And now if I hold the brass, oh my god, it spins with no resistance. Like, it spins nicely, but my god, that is powerful. You can really feel that torque. I think that's maybe something they're missing in their guide, is there's going to be a ton of torque in there. So, I'm happy with that. I think the alignment on this is good, and this one actually kind of popped up a little bit, so let's kind of work it back and forth. Yeah, they kind of popped in a little bit too deep. Okay. Well, we have no flatness. Here, so let's move on to the next step. So we have this, and we have those pieces. And let's see, there's no gap between the PG and the main plate. Can't confirm. That is all good. So we take that piece off, and we're looking for, make sure the rings are sitting flush. I think that's the one piece I'm a little bit weary about, so I'm going to try and spin it a little bit more to get a little bit more flushness out of it. And then we're going to go ahead and install this idler assembly. So the idler goes in to this hole right here, and it is then secured with the socket set screw. Do not over tighten the screw. The screw protrudes from the PG ring after tightening. Apply a small amount of Prusa lubricant all around the PG ring and PG assembly teeth. Oh my god, there's going to be so much lubricant in there. Alright, let's make sure we're happy, and then we're going to put in the 3x25 socket set screw along with this lever. Notice the screw facing upward, and this piece right here that's protruding, this is going to provide tightness for our screws. And it has decided not to grab my browser. So, apologies. Looks like the last crash actually broke some stuff. Let's look at that really quick one more time. So, this piece right here, going into that hole right there, we're using the M3x25 set screw, and then we're applying lubricant. And I'm going to jiggle it a little here to make it kind of go a little bit more down with those teeth. Let's go ahead and get all this stuff here flush. And yeah, it's interesting. Let's look through the bottom. Yeah, everything's sitting flush. But the, looks like the planetary gears kind of settled a little bit in there on the inside. So, they are not flush. And why is that they are not flush? Do they go too far down? Like, there's a noticeable step. Is this a step where we require Prusa's part? So I actually have 2 copies of the parts here. I didn't think I was going to have to do this, but let's go ahead and measure the thickness of the parts and see if there's a major difference. So the Prusa part is about 3.39 millimeters, and my part is, look at that, 3.41. I mean, that is a 0.02, so it's not even a 0.2 millimeter. This drop on these gears is, I think, more than that. So, alright, let's try doing some more jiggling. Trying to apply a little bit of upward pressure to see if I can get them to come up a little bit. Yeah, I don't know. I think that is a little bit low. Does that mean that they go below? Yeah, see, but I don't see them at the bottom, so they're not past the brass ring. They're within the bounds of the brass ring. And if my part were to be taller, let's go ahead and try one more time with all of this. Oh, it doesn't want to come off anymore. Gonna have to take all of these pieces off and drop everything and potentially destroy all of it. Let's measure this second part. So this is the part that was on there. Make sure we got 0. Look at that. Well, actually, you know what? This part, 3.43, that's a higher tolerance. So let's use this other part. Already taking some notes here on these parts, on what didn't go well. Let's use this part, because the thickness on it is just slightly smaller, and it might work better for us. And also, we get to practice assembling this thing one more time, so I don't think it hurts to practice this planetary gear assembly. So let's do this again on camera. I feel like I'm pretty good at this now, so I'm gonna try and do most of this where you can see it. I'm gonna place my PG assembly adapter on my planetary gears here. This brass insert with the part that is chamfered goes downward, and once it's sitting on the gears, I'm going to spin it just a little bit. Oh, that was really nice. It's just kind of popped right in. Okay, I'm going to keep doing these little wobbly spins until it is flush. You can't see it, but it is flush. So, happy with the flushness of it. And now once we have the flushness, we're going to install it right here. Now with this one, we're going to do larger turns. And we're looking for it to fall onto those gears that protrude from the extruder motor. Not applying any pressure, just spinning. Still trying to locate those. Oh, that's a little bit of clicking there. extruder. It's just done with us trying to attach this planetary gear. There we go. Alright. Oh, that flushness is just absolutely perfect on one side. The other side, it's not. And they spin, the planetary gears, but yeah, they're, I wonder if there a way for, how would I lift this entire assembly? Is it that it's dropping too far down onto the motor? No, it is not dropping too far down. And my part is not too thick for this. Alright, we're gonna proceed forward. It is not flush with the surface. It's almost there, but you could definitely feel that it's not perfectly flush. The next part is this extruder idler door. It looks like it's going to go in this way, and look at that, it has a little protrusion here on the side for it to go into there. Once we have that piece, we're going to grab the set screw, put it right on through. And it says not to tighten this one too much, so we're just going to kind of screw it in. We're going to need a super tiny Allen key. I do not know what the size of this one is. It's I think the tiniest one in there, because this is a set screw that we're tightening. So, and for some reason, why don't you want to go in? So you're not aligned with the hole. Now look down there to make sure that I have the, yeah, that looks like perfect hole alignment. Why does it not want to go in? I mean, I can actually see the threads at the bottom. I might have to give it a little bit of a jiggle. There we go. I guess this one is supposed to protrude like that. Here's where we're at right now. This one protrudes 2 millimeters. Is that accurate? Yeah, look at that. So secure both parts. Do not overwrite. The screw protrudes from the PG ring after tightening. Okay. So I actually just thought that, no, sorry, wrong step. I just thought that this thing wasn't going to go. But it protrudes. So I guess we're going to give it a little bit of tightening. Then we're going to go ahead and lubricate the gears. So we got that piece. I'm going to just lightly give it a, yeah, lightly give it a little bit of a tightening. And that's it. I'm going to go ahead and put this on to the top just to make sure planetary gear still moves. Looking pretty good. Not aligned though. Not happy with this. Hoping there's a little bit of wiggle room in there for tolerance. Alright, let us lubricate this thing. So, we're going to go ahead and we're going to put some lubricant on the inside on these gears, onto the planetary gears. I'm just going to kind of put a little bit on both sides. And on this one, I am totally probably putting too much lubricant in here. I'm going to just do one on this side. And then when they spin, they can lubricate themselves even more. I am not putting the ring on there, so I hope that's enough lubrication for these gears. Yeah, look at that. We did a lot more. Tip of a zip tie, then spread it around. really read instructions, huh? Alright, let me find there was a zip tie tip in here that I threw out yesterday. So let's go ahead and spread this. Oh, see, once you spread the lubricant, there's actually not that much. So that's that dollop. So funny to use the word dollop for lubricant, because dollop is usually sour cream. Okay, good there. Now this one, spread that all around there. Okay, I maybe did a little bit too much on the top. I'll take that right there, remove it, stick a little bit of it in there. Okay, and then I'm sure in the future when I have to disassemble this for some sort of maintenance, I'm going to be like, what idiot put all this lubricant in there? And that idiot will be me. It'll be that Taylor Swift song. It's me. Hi. Alright, back to the browser. Let's move on. Step 15, covering the planetary gear. Take the PG cover and make sure the plastic ring is already inserted. This part ensures smooth movement of the planetary gear. The color of the plastic ring might vary. The properties are the same. So we have the plastic ring on there. Cover the planetary gear and use a 3M3x25. Do not over tighten the screws. Sweet. So the place that already has this protruding screw has a matching hole. So look at that. So easy to align it. And our final M3x25 screws. Just gonna go ahead and pop them right in. I wonder why they, well, I guess by making that one protrude, they did make it really nice. Wow, these parts are not cleaned up at all. Let me go ahead and clean them up really quick. Screws don't even want to go in through them. There's like filament pieces in there. Make sure that. Wow, I mean the screws are screwed into the part. That is very tight with the tolerances. Same with this bottom one. What I'm going to do is I'm going to put the screws in since they are threading into this plastic part. For the part on the printer, they're going to go through brass that's not threaded, so they're going to pop right in. So I'm going to pull them out just a little bit so I can get the alignment, and then I'll continue to drive them forward once it's on there and flat. And actually, once I even have this, I can kind of probably push it through and work that piece out. Really tight tolerances on this. There we go. And this last one, push it through. Do the same. Just kind of move the screw around in there. Alright. And now into the holes they go. There we go. Wow. We almost have a Nextruder. How exciting is that? I read about this thing like a year ago and I was just like, that's so cool. I wonder how it works. I'm really looking forward to testing this out and learning how this planetary gear works. You know, gears are just fascinating because this is like a 10-to-1 gear. So it is going to be applying quite a bit of pressure, or torque, and it does not want to thread into the bottom part. There we go. I just had it misaligned. So that's a me problem. Make sure that the heat sink is aligned properly. Now I'm tightening this corner screw. Looks like that one went all the way in. We are threaded and attached to the extruder motor. Let's try this top one next. And because we have this one and that one, we kind of have the two corners, so it should create alignment for us. This one also, look at that, just went right in. I feel it threading into the extruder. And we're just gonna lightly tighten, close all the gaps, make sure we don't have lubricant leaking out of these. This one, there we go, went ahead and went through whatever was holding it back. And now we're gonna tighten this one. Okay. The instructions said not to over tighten these. Cover, do not over tighten the screws. Cool, so it's just a cover. So 15 out of 41, so that one's good, that one's good. Over tighten, the moment I start feeling resistance, I'm letting go. So, okay, this one kind of, some restricted movement. Maybe they are a little bit tight. I'm going to release them a little bit, just to make sure they're not too tight. And it's made that movement a little bit better. So I think this is going to also click in at some point, or, oh, I think that's it. That's the click, just like that. Very cool. Alright, moving on. Assembling the idler swivel. For the next part, we are going to need the idler nut in this maroon color, 2 idler swivels, and all these screws right here. So let me go ahead and prepare all of the pieces that we're going to need. I'll give me just a second here. Alright. And we're going to try to use as much of the ABS here as we can. So I got the idler nut and the 2 swivels. We are done with one of the Nextruder bags. Now we're going to need a bunch of parts. So some of the parts are going to come from the Nextruder bag of goodies. Specifically, the 2 springs are going to come, and those are the only 2 items left in the springs and magnets bag. We're going to need one of the 5.5 millimeter spacers, which there are 2 in this bag. So take one of those spacers out. And I think that's all from this Nextruder bag. Everything else is just your standard fasteners bag. So fasteners 2 out of 2 is going to have the M3 by, nope, fasteners 1 out of 2 is going to have the first one. And we also want to get, what are those? M3, those are nylock nuts, and M3 by 20 torque, M3 by 30. So let's see, what is in the fasteners 2 out of 2 bag? M3 by 20 RT screws are here, and the nylock nuts are also here. So bag 2 out of 2 has some of the stuff we need. These are the nylocks. And we are going to grab the torque screws that we're looking for. Is this them? Nope, that's M3 by 14. With something else. I did not actually read all of that, what's going on there. What is this? M3 by 20 RT. 3 pieces, 1 piece is spare, and we need 2 of them. So we are going to use all of the ones present in there. Nextruder, very, very cool. So let's go ahead and take those parts out. And I still need to get those M3 by 30 screws. I don't have those yet. So I got the torque screws. I'm going to put those off to the side. Now the M3 by 30 is in the fasteners 1 out of 2 bag. And those are your standard socket head cap screws. 11 pieces. And there are 2 pieces spare, and we need 2 of them, so there's still 3 in there. So an M3 by 30 still goes somewhere. Can't put this baggie away. Alright, let's make sure we got all the parts that we need. I think that's everything. The nylock nuts I need to take out, because I didn't take them out. We only need 2. There's 1 piece spare in the baggie, but there's 6 pieces. So that means that there is 3 more that go somewhere, right? That's good math. Alright, let's put this back in. Fasteners 2 out of 2. Just so I know where to look for it later. Good organization is key. Alright, we got the ABS parts for the idler nut. We have the 2 springs. We have the M3 by 30 screws. We have the M3 by 20 Torx screws. We have 2 M3 nylock nuts. We have those springs, and then we have one of the 5x5 spacers. So we are going to assemble the idler swivel. Push the M3 by 20 Torx screw all the way through one of the idler swivels. The idler swivels are both exactly the same, so it doesn't matter how you do that. Slide the spacer onto the screw from the inside. Place the second idler swivel on the opposite side. From the other side, attach the nylock screw. Hold the nut using the universal wrench and tighten the screw. Tighten just lightly. The spacer must rotate freely, so we want that thing inside of there spinning. So I'm going to move this off to the side, and let's try to assemble this. So we're going to start with one of these spacers. We are going to grab the M3 by 20 screw. That's this one right here. Notice it's going to have a Torx head. We're going to go ahead and push that through. It's pretty long. We're going to then take this piece right here, this spacer. We want it to be rolly. And we're going to put the second spacer on, just like that. And it protrudes a little bit on the other side. Then we are going to install a nylock nut. And the nylock nut is going to spin freely up to a point until we hit that nylon. And the moment we hit that nylon, we are going to need to use the universal holder. So these are actually some really cool parts right here, but I think what they want us using is this piece right here. So that is an M3 socket. So we're going to just hold it like so, and then I'm going to find the correct Torx wrench. It's the bigger one, and I'm going to use the Torx wrench to start tightening this screw into the nylock. And this is spinning freely, so it is not working for us. Let's try with this one. One of these has to be M3. Okay, there we go. That one is M3 size. Pretty happy with that. And then from the back, we're going to screw it in. It's going into nylon, so you're going to feel quite a bit of resistance. But I'm actually watching the part from up top. I'm looking for alignment, and I see a tiny little gap. I'm looking to get the parts mated together. Once the parts are together, oh, look at that. Even the parts being together is a little bit too tight because it stopped spinning freely, so to say. So let's go ahead and release it just a little bit. That was not even an eighth of a turn, but notice the parts, while mated, are still moving in there, but at least this piece is also spinning. So I don't think that I can get this piece locked in, so to say, and have the pieces aligned and not moving with that piece inside spinning freely. So yeah, look at that. The pieces still move, but the inside is already locked up. So I'm going to release it a little because I'm sure something else will help with alignment. But we do need to release it so that it spins inside. Does it spin? Wish there was like some sort of something on it. Yeah, see, it's not spinning. We need to get that piece to spin. I'm just doing like 1/8 releases on it. Need some more. Okay, the piece in there is spinning. I don't know if I call that freely. There's a little bit of resistance, but everything is spinning freely. So, alright, so we've done this. Step 18, with that piece, notice the direction where this hex screw is facing. We're going to insert the idler nut into the idler swivel. Make sure that both parts are oriented according to the picture. Secure both parts together by inserting another torque screw from the same side like the first screw. So there's going to be another torque screw. And we're also going to be putting an M3 nut. It must be possible to move with the idler swiveler on the idler nut. Okay, so this thing has to spin freely? I think that's what it means. So we have this piece that is the torque screw side. The other side has the nut. So with this piece oriented like this, we're going to go ahead and grab this piece. This piece looks kind of like that. So let's look at the picture really quick. It is the angled side. So this side downward, just like this. We're going to put it in here. I guess what they mean is this piece should, I guess, spin freely. So let's put this first screw in, go through the second piece, go all the way. I'm going to put the nylon nut on here. And we got that. And now, using that same technique, I'm going to install that piece. And this time, what if we try doing it the other way? I bet you it won't work. It's going to be just a pain. Yeah. Alright, I'm just going to use this to hold the nut in place as I, from this side, screw it in. So, that is screwed in that's actually screwed in pretty much all the way. I can actually, there's a little bit of a gap. I'm looking at the gap between the nut and the plastic part. There's a slight gap in there. So what I'm going to do is I'm going to close it. The gap is already really small, so the screw needs an additional maybe eighth of a turn. Yeah, that's already good. Already giving me a little bit of resistance, but not enough to make me worry. Worst case, this part could be readjusted later. Alright, so here we go. We got this little lever assembly done. Let's go back to the browser. So step 19, mounting the idler swivel. We're going to attach these springs onto the M3x30 screws. No protrude, and let's see, push the two screws with the springs through the holes in the protrusions on the heatsink. There are no threads inside. Attach the idler swivel assembly to the screw. See the correct orientation of the idler nut. The side with the two dots must be visible. See the picture. Tighten both screws. Stop tightening screws as the screw tips reach the front face of the idler nut. So we're going to be putting them in through here, through the top, looks like. And they are going to be going to that protrusion right there. So notice this piece, even in their photo, that piece looks a little bit misaligned. So it looks like if you tighten the pieces, you're just not going to have a good time. So make sure these two dots are facing upward. And cool. All right. I think we can get this done. So let's bring this toy back here. I'm going to go ahead and undo this because I clicked it earlier thinking, oh, it's so cool. Alright, and then I have my two M3x30 screws right here, like this, or like so. I'm going to take out these two springs from this bag. Spring 1 and spring 2. The springs go into the idler assembly as so, and there is nothing in there, so they just kind of slide right in like that. They are springy. And then with this, we're looking for the two dots on the part. A little bit easier to see on this part, going to be a little bit harder to see on their part. These are M3 nuts, so we're going to need our hex wrench for this. Oh, sorry, M3 screws, not M3 nuts. Okay, we got the leverage we want. And we are going to go ahead and tighten this into this plastic part right here. And they want us to tighten right as soon as the screw starts protruding from the plastic. So just kind of watch the assembly right here. what I'm watching for is for the screw to come out right there. I don't know that there is an orientation where I can make this easily visible. So I'm going to tighten it once we're there. We'll do a show and tell. And it looks like the once we get that, we'll actually be just flush with the springs as well. So we're still going into this plastic part. The springs have now engaged. So springs are doing a little bit of work, and there we are. All right, I can see that part right there. So notice how far it came out, and this spring actually engaged up top. So I'm going to align the part to make sure that the second hole is aligned, and I'm going to start screwing it in. Once I have the hole alignment, then I can get this thing done. And this might be a good view right here. And I feel the thread happening. And I can't see it, but I can see the camera. So you can watch that piece come out. And we're going to go to about the same distance, just barely protruding out the other end. Both screws are about flush. So this is what it looks like now with this piece kind of dangling. This is going to lock in somehow. It's going to be a really nifty mechanism to apply tension. And actually, if you look in here, there is a massive gear in there that's going to be pulling filament, applying a lot of surface area. And then there's two rollers right here that are going to push the filament against it. So we're going to have really good filament control with this Nextruder. So very cool. All right, attach the extruder parts. More parts. So we are going to need 2 thumb screws, 3 M3x10 screws, a M3x4T grub screw, and the NTC thermistor. NTC. Nextruder. Huh. I guess we will find out what we screw it into and what a NTC thermistor is. I found the NTC thermistor. It's in the same box as the extruder, or I guess the hot end. The hot end does have a thermistor and it's already attached. So, all right, so we need these the 2 thumb screws. I'm going to do this one in order so it'll be easier to kind of check the pieces off. So thumb screw 1, thumb screw 2, and now the M3x10. I have it in a special baggie that's M3x6. It's M3x10. We need 3 of them. There's 3 M3x10s and a grub screw. Grub screw is such a funny name. Because isn't grub like ants or something? Or bugs? And it is going to be in fasteners bag 2 out of 2. So M3x4 T. Oh, T. I wonder if that means it's going to be a torque grub screw. Now, don't get confused with M3x4 BT, because what we want is we actually just want a grub screw. So the grub screw is the one that does not have a head. Oh, and this makes sense. So I said earlier that there is even smaller torque screws, and I'm over here thinking, like, did they really use like an M1 screw? Like, do M1 screws even exist? Those are so tiny, and what would that even do? They are actually just using a grub screw that is Torx. And by making this grub screw a Torx screw, there's one piece spare in here, so we're done with this one. You just need the smaller tool. So they are not actually using a smaller screw, although that is a very tiny M3 screw and the thermistor. So what we are going to have to do here is on the extruder motor side, so we're going to flip the whole thing over to look at the motor. We're going to insert the NTC thermistor into the hole in the heatsink as pictured, and then we're going to install that grub screw from the top. We're going to tighten gently but firmly using 2 fingers at the short side of the applying more force may cause permanent damage to the thread. So this is just to hold that piece in. We don't really need to go crazy. The 2 thumb screws go right here on the side. Do not tighten them completely. 2 turns are enough for now, so just putting those in. And we are actually going to, looks like we're going to mount the extruder. And be sure not to pinch any of the cables. And that's where the M3x10 screws come in through that extruder. So let's do this in order. Let's get this thermistor attached first, being very gentle. So the thermistor is going to go, here's the motor. Did I mount this correctly? I think I mounted this incorrectly. I think earlier when I was moving everything, I think this motor turned. Notice the direction of the cable. Should the direction be matching all of these? Or yeah, look at that. I did something incorrectly. At some point, I was messing around too much, and my motor actually shifted. So in this photo, looking at the parts at the bottom, notice where the Prusa logo is, and notice where the cables are coming out of the motor. Mine does not look like that. Mine is rotated 90 degrees, and I think I actually know what happened is when I was trying to get the planetary gear aligned, I got that moved. So, okay, I do know how to fix this. What we're going to have to do is we're going to have to remove these 4 screws right here along with this screw down here at the bottom. We're going to turn the motor, and it's going to turn freely on its own. And then we're going to go ahead and retighten those screws, starting with this one and then these 4. And that shouldn't cause any sort of issues as long as the gears are still, fully aligned. We'll be turning it on the correct axis. But we are going to need to release these screws. Oh, what a good catch. Imagine mounting this thing onto the motor. I feel like with the guide, if I was going to provide some feedback, it would be that after mounting the gears, double check your motor didn't move, because I bet a lot of people's motors would just probably move a bit as you're trying to get that gear to go on, and you're reading all the warning signs. Warning, warning, make sure that this is aligned properly. You're probably really worried about the alignment, not looking at that motor. And I thought I was doing a good job watching that motor cable, but I guess not. I just missed it. So, it's okay. It's fixable. The world has not yet ended, even though it might feel like it. So, let's go ahead and remove these screws. I think they've kind of threaded into the plastic a little bit. Yeah, they're still threaded in the plastic. Alright, I think they're released. Okay, this back one is definitely released. That one just popped off. And I think that one is giving a little pop. Okay, awesome. I'm going to leave those on there because we're about to fix them. Let's remove this piece right here. So unscrew and remove the grub screw. Then we're going to remove this piece right here. The motor will now spin freely. And we spun the motor exactly where we want it. Now let's go ahead and put this first screw back in. And we're going to go through this hole, get the right alignment. Okay. Gonna give it a little bit of a tightening, not anything major. And then we're gonna reattach this top plate. Oof. I think the one thing with doing this is I noticed that the motor spun really nicely in there too, and I'm really happy with how that planetary gear came out. So be sure to double check your cables. Maybe they can add that into the guide as a recommendation. Because my motor shifted when they were like, wobble the motor left and right, you know, for funsies. Alright, let me go ahead and release that one just a little bit. So everything is tight, but still moves. Okay, let's go back. Now, this photo looks correct. Notice the Prusa logo is upside down, facing this right here, with the cable coming out. It is going to match the browser right there. So we can now continue with this thermistor. The thermistor is going to go down through the top, and we're going to attach it with the grub screw, one step at a time, not applying too much pressure, because this thermistor, it's just a thermistor in a metal body. It needs to be held in place. It does not need to be screwed through. So it has a really nice fit. Let's see, did they say how far we want it coming through? So on the extruder motor side, insert the thermistor into the hole. Secure it, tighten, but use 2 fingers, applying some force. Insert 2 thumb screws, do not tighten them. Okay, so the thermistor is just going in there. There's no necessary depth. I think what you'd probably want with this is the metal is going to be measuring, a thermistor is going to measure temperature. So make sure you have as much metal contact on metal, and make sure it doesn't come out the other end. There is a sweet spot. And what's going to be annoying with this is working with 2 hands to get the alignment. So the trick is, put the grub screw in first, just to pre-thread it. Get it where you want, where you have the leverage of the grub screw. Then align the thermistor, and then screw it in. And once you find the spot where it starts to grip the thermistor, right, so right now I'm wobbling this thing up and down. I'm just looking for it to grab. Oh, there we go, it's grabbing. Now once it's grabbing, I'm going to release it just a little bit. I'm going to align the thermistor where I want it, and I'm going to tighten it. And now that it's tightened, I'm going to also tighten it a little bit more, but just like that much. I want to say that was 1/8 of a turn. Just a little bit. You don't want to damage that thermistor. You don't want to crush the body of the thermistor. Next is the grub screws. The grub screws go on this side right here. They say 2 turns is enough right now, so just get it threaded. We're going to get it threaded, and then we're going to go 1, 2, 3. I say 3, but it's 3 turns, so it's probably 1.5 threads. Plus the part where it grabbed. So, okay, come on, grab the thread. There we go, okay. 1, 2, 3, and that's about enough. Alright, let's go back to the browser. So we've finished step 21. We are now going to attach the extruder. So place the Nextruder onto the spacers. There is a cutout in the plastic part. Guide the thermistor cable through this cutout. Do not pinch any of the cables. So notice that the motor is going to go straight in. There's the thermistor cable, this one right here, and it's going to go, I don't think you can see my mouse, but we'll look at it on the part where that cable needs to go through the printed part. And then finally, we're going to align the heatsink holes with the spacers, and we are going to install the M3x10 screws. Start with the middle one, so I think it's just middle out. Alright, so this part is built. Let's now take a look at the bigger part, or the bigger part, the 3D printer. Okay, I think we're going to need one of these. Move these parts out of the way, and let's bring this thing in. you'll notice that there is a cutout right here. That's where the thermistor cable is going to go. So we're going to go ahead and place the Nextruder on, and we're going to guide the thermistor cable out through that hole. We are going to align it on the screws, and honestly the thermistor cable just kind of falls in. It's not an extremely precise fit, but let's go ahead and get that middle one installed. And I grabbed the wrong Allen key. I need to label them or something. So starting with the middle one, I'm just going to install it. I did no tightening whatsoever. So I got the middle one installed. Go and install the top one right here. You might have to do a little bit of jiggling to get it into place for it to fall onto the threads. I think right there is where the threads are. I'm going to do the bottom one because I could see the threads. Or maybe I threaded this one too far and now the other threads don't want to grab. Come on. It's funny because when you look through the hole you could definitely see the threads. Okay, that one grabbed. And this one. It looks like there is a slight misalignment. I think this is where, yeah, I don't think that's gonna align. Yeah, it is off by a little bit. So maybe let's look at the bottom part, see what's going on. Maybe one of my spacers is just not aligned straight. Maybe this one could be pushed a little bit upward. Do I still have access to these through the back? Oh, look at that. I could still get into these from the back. There's holes that are made. Oh my god, there's no way you're getting anything through those holes. Holes are way too small. Yeah, no, it's not working. I do think that is the hole to the right place, but I don't think it actually will allow me to adjust this. Alright, let me try one of these tools here. Yeah. Nope. I have an idea. That idea involves a M3x10 screw and tension from the top, where maybe I could get it seated a little bit better by screwing it in. Yeah, see, like even this one just kind of points downward a little bit. So let's try and fix that here. So I'm going to tighten this screw, and look at that. I think just tightening it from the top helped a little bit with the alignment. I'm going to test this bottom one too, to see how we are. I think that was more than enough movement for that screw. Yeah, that one looks pretty straight to me. Let me go ahead and watch. Easier to work on everything. And this one, alignment is pretty good. Okay, let's try one more time But I'm going to remove the screws, and I'm just going to look at the alignment holes on it first. Let's see what we got for alignment, because if we don't see it, then it's not going to happen. So, yeah, I am still missing a little bit of alignment on this top screw. And it is just the slightest amount, so this top screw needs to either go a little bit up, or the bottom one needs to go a little bit down. So, I am going to try and do that. Yeah. I can actually, like, looking at the top one, I could see that it's not straight. So, the bottom one I'm very happy with. I'm very happy with the direction that one's facing, but this top one, so I'm going to screw it in. At some point it meets the other screw. Oh, there we go. Did that? It went ahead and it clicked in to the plastic piece. Oh. Okay. I'm happy with where it's at, but I don't want it to move. So, can I unscrew this screw without it moving? There's a step in the manual where they have you make sure that this part sits up there really nicely. Very, very important part. So let's check that alignment one more time. It's still off by a little bit, but a lot less. And I think I can now make it work at least. So let's get the middle screw on first, because that will just hold everything in place for us. So middle screw first, that'll hold the Nextruder there. Do the top screw here. Jiggle it a little. Oh, maybe if I use the right key. Wait, no, that was the right key. Was the screw spinning? Yeah, look at that. It is just spinning. Okay. Gotta jiggle it. This one is a little bit too tight for jiggle. There we go. Okay, that one grabbed. And now, the moment of truth is the bottom one. Based on just looking in. Come on. Don't have any nails to do that. Yeah, the screw alignment on this one is not that good. I think this is where that printing the parts a little bit bigger would definitely be helpful. I don't want to introduce unneeded tension here, but I feel like I'm introducing unneeded tension. I'm going to apply a little bit of pressure onto the nut to see if I can get it to align better. And I seemingly cannot. This is where we are going to have to maybe eat our pride and reprint this part correctly. Yeah, that's not moving at all. Oh, there it is. If I can just get the screw to thread. Oh, we got it? I think we got it. Nope. False hope. Yep. Alright. I think with this, just based on where this is at, based on this metal part here actually having parts that do load cell measurement. I guess the load cell isn't there, so if this part was a little bit tight, it wouldn't hurt it. But why don't you want to attach? It is off by like 1/10 of a millimeter over here. Alright, let's be a perfectionist on this one. So what we're gonna do is we're actually gonna stop here. I'm going to disassemble this. We didn't get through the full Nextruder assembly, and that is okay. We are actually gonna have to start doing some maintenance already. So I'm gonna push this off to the side. What we need to do is we need to reprint this entire part right here. And we need to print it slightly larger. So this part was not reprinted. It was a part that I was a little bit worried about of it not being reprinted, and things were going well, and I thought it was going to be fine. I was wrong. So we're going to reprint this part. I'm going to reprint this part in the correct dimensions that I currently believe to be true. What I'm also going to do is I'm also going to try reprinting this cover here. I don't even know what I wrote on here. Oh, scale. You need to scale this part up, make it a little bit bigger so that when it shrinks to the right size. So yeah, I guess that's where we're at right now. Oh, disassembling this is not going to be fun. But we have to disassemble it. So if you'd like to stay for the rest of the stream, we're going to disassemble this part right here. And then I'm going to take it back to the drawing board along with a few other parts that I have and notes that I have. I will reprint them, and we're going to try again maybe tomorrow. Or if not, then in a few days. We'll be back. So I'm going to start disassembling this. So to disassemble this, I'm going to remove the love board. I guess all the parts here on this carriage I'm going to reprint. Might as well. Not going to take that much longer. So this piece, put it off to the side here. And then there's a few other pieces in the back. Look in the back. This piece holds the love board in place. I believe it's the N3x6. Yeah, it's a much shorter screw. And then there's these two screws that just hold this entire thing in place. Oh, this might be a huge pain, having to redo all of it. Maybe there's a way we can get away with it, where we don't have to redo all of it. But putting the cable in and having no slack to do any of the work, I'll be able to disassemble a little bit of the cable and give myself some slack, so I am not that worried about that. Let's go ahead and disassemble. So okay, that has been disassembled. Now will it come out? Come out to play with us. Okay, we got one of these screws. We're going to put the screw off to the side. We're going to have to look at the screw reference on these later to figure out what these screws connect to. Because I am not going to remember. This is not coming out because this is holding it. So let's disassemble this cable connector here. Okay, got that disassembled. And now we're going to have to clip those pieces off. I need to find my clippers. They're somewhere here. Clipper is also the name of some open source software for running 3D printers. So if you don't know what Clipper is, you should go check it out. It's actually really cool. how easy it is to cut these open. Not easy at all. Oh, actually, you know what? That wasn't that bad. I take my complaint back. I'm also going to scale these parts up, so it'll just be a little bit easier to assemble it. And when I say scale these parts up, I mean the scale is so minuscule already, but I think it'll make all the difference. So we got those parts out. This part should just slide right out now. We're going to go ahead and make this part also bigger. So let's put that off to the side. And interesting enough, that part was already, I guess it wasn't really holding the pad better. So hopefully when we make it bigger, it holds the pad just a little bit better. That nylon piece is in there. Let's go ahead and get this love board removed. So I'm going to remove the connector on it, and I'm going to disconnect the love board here on the other side. Come on, love board, let's go. Okay, got the love board out, placing it off to the side. Okay, and disconnecting that nylon, being careful not to damage it. And now to take the cables out from this connector. It's going to be easy if I give myself a little bit of slack like this. And we start with the braided connector. Ah, the beautiful braided connector. You know, it's so well hidden. It's such a beautiful cable. Yet it's hidden all the way in the back and you never see it. So let's start with this braided connector right here. Okay, we got the braided one out. And now just the connector bundles. And we're disconnected. And we're going to have to reconnect that x-axis as well. So let's go ahead and start by tipping this part over and releasing the x-axis belt. Worried about this one. I don't want to damage the belt. Can I use the needle noses to just kind of grip it, pull it out? Yeah, that belt is pretty rubbery. So we got one of the belts out. I'm going to try and leave it in the same spot so that I can retighten the belts the same way. Okay, and pull that belt out. Alright, belts are released. And then there's these 4 screws here at the bottom that we have to untighten. I keep grabbing the wrong one. Why do we even have that one out? I think I used it once. I wonder if other people do the same thing where you put a tool on your table and you just keep grabbing it even though you don't need it. I remember threading this was also really, really tight. So by scaling these pieces up, we will have a better experience. I think what I'm going to find is that all the parts are just going to have to be scaled in order to actually make this work. And I have a feeling that's going to be the hard lesson here. So, okay, we got this, and we got this, and we got that one out. Did we already unscrew this one? Not at all. That's why this part is still holding. There we go, it's starting to release. Okay, I think it's released from the square nut, and now we just gotta pull it off. Yep. And I'm gonna do that, and I'm gonna lose some square nuts. I'm gonna remove it here on the motor side because I think the motor side is just gonna be easier to rethread and pull this out. I'm gonna make sure that the idler is still in there. I don't want that idler pin to fall out. That'd be a pain in the behind to fix. And let's go ahead and disassemble this piece further. So that piece can go back there. We're done with the 3D printer for tonight. I'm gonna find the love board's packaging and put it back in. Look, I found a bag for the love board, and the love board is just gonna go in there. It's gonna keep it safe. here, so these two zip ties are going to go to the zip tie pile. We're going to remove these 4 screws. And then these rubber pads. The rubber pads on this actually come out real nice because on the back they've made a little spot to push them out. So you just push them right out. Don't know why that exists. Don't know why you would ever change this part. On my Mark III, I've never changed the X carriage. I'm actually thinking of reprinting it. And now to remove all the square nuts, because they were all over the place. There was like 6 or 7 of them. Alright, see, I was working on this one right here. Remove that one. Let's remove the top one. Also, I just finished a 3D print right now, so it'll be good. I'll just go ahead and replace the filaments with this gray one, and we're off to the races, printing the parts that we need. These are also not that tight, so by making the parts bigger, let's see, where do we print from? We print from there, so it should be the same height, which is what's giving me the grips. Okay, I think these will be fine when we scale up the holes. Okay, we have that. Look at that. This one's just popping out, ready for us to take it out. So we got that one. There's this one right here. I think this one didn't want to go in, so we might have to cut it out. And there's this top one right here, which is coming right out. So, okay, we got that. Just kidding, we do not. Alright, let's do some destructive removal. So, cut that out right there. And cut on this other axis. And we have the nut out. So that's that. And then this one needs to be removed as well. So let's do some destructive cutting. Look at that, the whole piece just breaks. And then we remove that nut. Alright, and now to move on to the next pieces. Here, the M3x10s holding the normal nut and the standoffs. Looking at the positive side of things, by the end of all of this, I will have assembled this 2 or 3 times, so I will probably feel really confident in being able to assemble one of these in the future. See, and then this nut right here just needs to be pushed out. Okay. I think, oh, there's one more nut right here that needs to be pushed out. Wow, this one doesn't want to come out, huh? It's coming out like half. Oh, there we go. And the floor monster is going to get it for sure. I'll grab that one in just a second. I think we are good. We've removed all the visible and invisible screws from this part. There's no other pieces. I'm not going to throw this part out. I'll just have it available. So, let's see. We're going to reprint these two. And let's see if there's anything else. So, part-wise, there's an LCD cover. We can try putting that on the LCD right now just to see if we need to make some adjustments. There's a PSU cover, I think, which we can try putting on right now. So I think that's something that I'm going to do just to see if I need to reprint it. Generally, those parts might just have better tolerances, and it might be okay for us not to reprint those, but you never know. So I already have a pile here. I'm actually going to start a box rather than a pile of parts that need to be reprinted. And some of these I've already reprinted. So these need to be reprinted. I'll be able to identify them later. I'm not going to reprint that one. Those are reprint. Let's put this away because we don't want to lose it. I'm looking at the Nextruder. I have the LCD here, so actually, this is the LCD. The X carriage and heat bed. We can actually try some of these parts just to make sure that they fit. Filament holder is not going to be reprinted. I'm sure that one will be just fine. So, okay, let's go ahead and let's do some part assembly and see what fits. So I got the LCD screen right here. And I'm going to take that LCD screen out. I'm going to grab this LCD screen cover here. And it goes on like this. And is it actually going to fit? Look at that. I don't think it wants to fit. As compared to the one from Prusa. Oh, the fit on this one is much nicer. Yeah. Yep, that fits a lot better. Let's, wow, I didn't think that the fit was going to be this tight on the LCD. So, let's, you know what, let's just be safe. Let's reprint that too. So LCD cover back in the bag, and LCD cover into the reprint pile. Learn something new there. Even the LCD cover has exact specifications. Love the engineering, but it's really hard to have tolerance. So, okay, this part from them is good. You know what? While we're at it, let's go ahead and reprint the seat for the LCD cover as well, just because the screw holes will align better. All that's left is the PSU and the knob for the LCD. I'm going to get that LCD back out, and then we're going to check the knob for it. Where is that LCD? It's in here. Oh, LCD. Now, come on, this tolerance, especially for such a small part, can't be that crazy. So let's see, flat side goes here, or flat side goes here. How does this part attach? I think it attaches like this. Yeah, that's also really tight. Wow, even the knob just has insane tightness. Okay, let's reprint the knob just to be safe. So much for having a cool, colorful knob. PSU cover. That goes on the PSU. Right down here. How are we with tolerance? Oh boy. This does not make me happy, seeing everything rolling around. You know what? it is just off by the slightest bit. Let's reprint it. We're already reprinting all the other parts. Alright, so this needs reprinting. The Y carriage and heat bed cables. Let's go ahead and take a look at these. Alright, these pieces need to go onto these rods, and you can't see anything, so let's fix that right now. Printer could go right here. Here are the parts in question that we're thinking about, right here. So these parts are going to need to fit. So these parts should actually fit into one another, just like so. And, oh, they actually fit, with the screw holes all aligned. I kind of like the color. Alright, let's not print this, because this part could always be fixed, worst case. And if I have to reprint that one, I'm definitely reprinting a colorful knob. You know what? This piece looks like it is the Y-axis holder for the cable that's going to attach to the moving gantry. It looks pretty specific, so let's reprint it. I'm not even going to measure it. These pieces that attach to the rods, let's grab one of the Y rods. This is a Y rod holder, and that is extremely tight. I think I can get it to work, but you know what? It's another rod. We had problems with the circles. Let's reprint them. So we're done with this bag. And moving on to the final bag, which is the Y carriage and heat bed 2 out of 2. There is, let's see, there's this little Wi-Fi clip, which I think these are all the way at the end. Huh, I wonder what this is. I'm not going to reprint it. I assume it's something I could, at the end, reprint in color if I wanted to. So I'm making that decision right now. This is going to be some sort of cable clip. It's in color, so I'm not going to reprint it. Same with the Wi-Fi cover. If we need to reprint them, they're probably at the end, and they're probably going to be in color. So, alright. We got quite some work to do. Here's where we're at right now. We took a step back. We found out that the parts for the extruder for the extruder carriage that goes on the X-axis, the tolerance is just a little bit too tight. We didn't reprint them. I thought that it would kind of work, although I did have my doubts, it being the X carriage for the extruder, and having tighter tolerances, that, you know, this might not work. And lo and behold, it did not work. So, thanks for watching. We're going to go ahead and reprint those parts, and then hopefully we can get back to this soon and continue building.